Hi, I'm Ryan Smith.
Hi, my name is Matt Illo.
Hi, I'm Kieran Severance.
And I'm Nathan Jacks, and this is the APHIS ORV Delivery System Senior Design Team.
The background of the project is to prevent rabies transmission in raccoons. Raccoons are the greatest rabies transmitters on the East Coast, which is where this project takes place. Currently, the USDA drops vaccinated baits from the air and the ground. They use planes to drop large payloads over the wilderness. On the ground, workers throw baits out of moving vehicles into the wilderness from the road. Workers also hike in to refill strategically placed bait stations. And relevant to the current project, helicopters drop baits selectively around urban areas. Now, this project improves the helicopter distribution of the baits because they're having difficulty distributing, counting, and geotagging the baits with the current system. The problem statement of the project has a few different elements. One is to record the quantity and location of the distributed baits. This is to get some good data in order to evaluate the effectiveness of the program and to make modifications based on that data. The second part is to increase the adherence to the bait plan. Currently, operators don't have an effective way to precisely distribute the baits, and we aim to improve that. The third part is the device requirements. The device has some specific requirements due to being in an aircraft. It has to be light, it has to be robust, has to be easily repairable, user-friendly, and fully automated.
With this problem statement in mind, our senior design team set out to create an oral rabies vaccine distribution device. Through our meetings with the USDA, we learned about the different device requirements, which led to us making a list of objectives we wanted the device to achieve. Shown here are some of the objectives our team went for, such as having the device geo-track the baits as well as count them accurately. Other considerations our team had to think about were the constraints the device had to fall within. This table here shows various constraints that were considered during the design phase of the project. After several mock-up designs were considered, one final design was chosen that we were going to create. The chosen design involved a conveyor system that required an in-depth design process to create the optimal design.
The counting and sorting system of the ORV design was the most dependent portion of the device, as it was the only moving part. We had considered using paddle wheels, optical sensors, or maybe even just a manual button to signal a bait leaving the device, and we chose a variable speed conveyor which runs off of a rate of baits released. We decided to ditch the old polyethylene bin, as it's not very great for the environment for one, and it's also heavy. It's not very sturdy for any sort of consistent system, and using something like the 80/20 aluminum frame was very easy to mount things and to adjust certain parts, as it's very finicky. As for the hopper, we had looked at spinning drums, conical vibrating shapes, and even spring-loaded bait cartridges, and we decided that just to keep it more simple, to keep things running well, and reduce the amount of maintenance and cleaning for the device, to go with just a basic hinged inclining hopper based off of that pulley system.
Overall, the design process for the bait distribution device had a couple steps. We can see that it initially involved several cardboard testing devices as seen here. These helped us narrow down our design choices. Multiple CAD models for flywheels and pulleys were created, modified, and 3D printed for testing with the device. Other testing rigs were created for the hopper design, which led to a prototype that incorporated the design components. This prototype features a basic bait feeder hopper and a conveyor system that drives baits into the exit tube while the operator is holding the device in their lap. Our team was able to get the conveyor belt up and running, as well as assemble many of the structural components on the device. Further modifications and testing are needed before this specific device is ready for field use.
Let's have a look at the function of the GPS system and what it consists of. The GPS system utilizes in-flight parameters to allow us to determine the location of each bait dropped, as well as how many baits are dropped from the helicopter throughout a given flight. The system is built around an Arduino Mega with an Adafruit Ultimate GPS data logging shield and is powered by a portable battery pack. An LCD interface allows the user to determine if the system is functioning correctly and has a satellite fix, as well as toggle a switch to select the desired form of bait density to be dropped. The system's code was written in Arduino and was reiterated several times to be able to ensure function, fail-safe, and overall user-friendliness. With the bait system requiring some further development, the GPS system was modified, giving it its ability to operate in either a standalone unit or a fully integrated one. The standalone option is one that is ready to be implemented in current bait dropping. It performs by calculating its in-flight parameters and adjusting its function to simulate baits dropped with proven effectiveness. The integrated system has the ability to control and run the entire system, but as mentioned, requires a little bit more further development.
In summary, our team worked with the USDA to create a device to track and distribute oral rabies vaccines from a helicopter. We created many potential designs to manufacture, and through the design and manufacturing process, we're able to create a standalone GPS tracking system as well as a prototype bait distribution device. Thank you for taking the time to learn about our project. We would like to give a special thank you to our USDA sponsors, Amy, Bradley, and Bob, and would also like to thank our Colorado State University advisor, Dr. Troxel, and our TA, Ali.